I'm Dr. Joseph Ross from the California State University Department of Biology, and I'm sharing two approaches I used last night, October 25th, 2016, in my graduate molecular biology class to celebrate Active Learning Day. The format of my class is we read a published scientific manuscript and we discuss the figures. And my students come mainly from Master of Science in Biology and Professional Masters in Biotechnology programs. I have a diverse audience in my classroom, particularly among science backgrounds. Not only do I have chemists, but I have biologists of various specializations, including ecology, microbiology, and cell biology. And so active learning is really important in my class because it is 3 hours long from 6 to 9 p.m. And when energy is really flagging at the end of the day, it's good to incorporate exercises. The approach that I'm going to show you doesn't have to take a lot of time on the part of the instructor, but the investment the instructor makes pays huge dividends in having the students become more engaged in the classroom, as you'll observe in this video. Last night in class, for the topic of the molecular biology of translation of messenger RNA into protein, we read this manuscript, which was published in Nature in 2012. Two hurdles I have to overcome with this manuscript, as with many, are, first, helping understand the big picture questions like, why is this topic interesting and important to study? And two, helping students conceptualize what intermolecular interactions are occurring in the cell, what each protein or molecule is doing. For this manuscript, as with many, jargon can be an obstacle to deep understanding. This is supplementary figure 2 from the manuscript, which displays the names of key proteins and molecules, like oxygen, the 7-methylguanosine cap on the messenger RNA molecule, HIF2 alpha, a protein, eukaryotic initiation factor 4E, and the 4E binding protein. Today I'm highlighting how I used the think, pair, share and the kinesthetic learning strategies to help overcome these barriers to deep understanding. I like think, pair, share because it facilitates interaction of students who are often hesitant to ask questions or to offer opinions and interpretations in other classroom settings. Last night, I used this active learning strategy to have students brainstorm why the particular topic of the class meeting is relevant. Here's a clip of how deeply students became engaged when I presented them with a type of question that they don't often hear in a science class. I asked them to form small groups and then discuss which one step in the central dogma of biology, which is DNA encodes RNA encodes protein, and decide which is the most important step, DNA replication, transcription, or translation, and be able to explain their reasoning to the class. Later in the class period, I employed kinesthetic learning to help students experience the molecular interactions involved in the regulation of translation. In the movie clip that follows, I'm assigning students roles as different molecules and proteins by handing them pieces of 8.5 by 11 paper with those characters printed on them, like the 60S ribosomal subunit or a phosphate. And then the students act out how the process of translation changes in the presence and the absence of oxygen. Since this class is meeting just before Halloween, I spiced up this activity by using a long screen of Halloween tinsel to represent the messenger RNA molecule to be translated, and I brought a cauldron full of candy to represent the protein products of translation. Here we go. Who's got the 7-methylguanine cap? All right. You need to be attached to the messenger RNA. So you're on the 5, that's the 5' end, I'm the 3' end. Yeah, okay. And I've got the translated products in the candy basket. There. So when our ribosomes get down to the end, you've actually synthesized some sort of candy. Okay. So let's see. Right now we've got a lot of oxygen around.
Yeah.
Right? How many oxygens are there? Raise your hands. There's 1, 2, 3, 4, 5, 6 or so oxygens. Okay, so we've got a lot of oxygen around. What's going on when there's a lot of oxygen around? mTOR is here.
Yeah, mTOR is here.
Okay.
EBP is.
So what does mTOR do to 4-EBP? Okay, so mTOR, you better grab the phosphate group. Yeah, so bring the phosphate group over here. mTOR, bring the phosphate group over here. Yep. And then you attach the phosphate group to who? Who gets the phosphate group? Where's 4-EBP? Okay, so 4-EBP, you're about to get phosphorylated. Okay, that's what the clip's for. There you go. See, this is high tech. Okay, so now 4-EBP is phosphorylated. Okay, 4-EBP, now what are you and the phosphate group going to do? You're active.
Yes.
So you're going to have to go find EIF4E and... Yep. You don't have to physically bind to it if you don't want to. But you're going to go repress EIF4E. Take EIF4E away. In the presence of oxygen, all three of you. Yep, you're a 4E binding protein. You bound to EIF4E, you take her away. Okay. Fair enough. So did you get translation or not? What are you 40S and 60S ribosome subunits going to do?
We're not going to find it.
Right, you've got no way to, because what do you subunits of the ribosome need to be able to bind to the 7-methylguanine cap? EIF4E, but EIF4E just got repressed. Okay, so if you guys want candy, what are you going to do next? I mean, if you want to translate this fabulous messenger RNA, what do you want to do next? Okay, go away, oxygen. Go sit back down. You're not needed anymore. Thank you very much for participating in the play. Okay, so we're going to do hypoxia. Get out of here. So we're in a hypoxic situation now. So who's gone in hypoxia? By some mechanism we don't know. Okay, so mTOR, you're out of here. Okay, true. Okay, so that means that 4-EBP is not phosphorylated anymore. So 4E binding protein does what? Does not. Right, so you two are not repressed anymore. So finally, we've released EIF4E to go grab the 7-methylguanine cap, guanosine cap. And there's a ribosomal party going on because now, 40S, yep, and a 60, you'll need a 60S, Maria. Don't need 60S, okay. So you're going to bind the 7-methylguanine cap and then translate this direction down the messenger RNA molecule, the pair of you, and you get candy. And then, yep, exactly. So now what are we doing? You have lots of ribosomes translating all at once, and this is a polysome. Fantastic. Yep, that's it. My favorite part of this activity, and the one that tells me I'm absolutely engaging students, was the laughter. That's authentic from the students. They're paying attention and they are engaged. I'm Dr. Joseph Ross from the California State University Fresno campus, Department of Biology, and this was how I celebrated Active Learning Day 2016.